Hi, and welcome again to the CDFM study group. My name is Helen Thomas, and we will be continuing the review of CDFM Module 2.2, Cost and Economic Analysis. We're going to pick up on page 2.2.39, and we're looking at the families of contracts at the bottom there. So the two families of contract is fixed price, where the government pays the price, subject to some maximum ceiling amount if a sharing incentive is used. And then cost reimbursement, where the government pays the cost subject to limitations on allowability, allocatability, and reasonableness, usually along with some kind of fee. Each category consists of several different types. So the two families of contract, fixed price and cost reimbursement. On the top of page 40, in the fixed price contracting, the majority of the risk is on the contractor. Fixed price, meaning it's one set price for the contractor to do the job, so the majority of the risk is on that contractor. In the cost reimbursement contracts, the government promises to pay, as we talked about earlier, but the government may not allow the contractor to continue working at his own risk if additional funds are not obligated to the contract. So if you hear about stop work on a contract because the contract ends and we don't have a new contract in place, that's most likely a cost reimbursement contract. So it says that you have to already have the additional funds obligated on that contract for the work to continue. In these contracts, and I'm reading the third paragraph on page 40, the government bears a potential significant financial risk. If costs go up beyond the original negotiated cost, the government must pay those allowable, allocatable, and reasonable costs. Because of the potential financial risk in cost reimbursement contracts above a specific, as mean cost reimbursement is whatever it costs, the government has to reimburse that contractor. So because of that, the government imposes the earned value management system reporting requirement on the contractor, and the DODI 5000.02 prescribes the type and level of reporting required, which is customarily based on the value of the contract. And the earned value management is discussed on page 41, so we can go ahead and switch there. And it's basically in the beginning, the contractor has to give a budgeted cost estimate, how long it's estimated to take to do the job, the costs associated with it, and the earned value management is that periodic check to see how close are we to the budget estimates. So on page 41, it says, earned value management is an integrated tool that relates technical performance to its associated costs and schedule, measures the work progress in objective terms, and states the value of the work completed in dollars, so we can understand things in dollars. Earned value is structured around multiple work packages. The result is known as the budgeted cost of work schedule. So based on the timeline that you say it takes you to get the job done, we estimate a particular cost for that work, and that's the budgeted cost of work schedule, which is also called the performance measurement baseline. The PMB may also be considered the planned value. So your estimated value, your planned value, your performance measurement baseline, cost of work schedule all mean the same thing. So that annotate that on page 41. All right, page 42 at the bottom, looking at earned value management report analysis. Variances fall primarily into cost or schedule variances, meaning when we do look at the estimate versus the actual or the budgeted amount, we need to be able to see what's the difference. Did we come on target, or are we over or underrun? So cost variance is a result of comparing actual cost of work performed to the budgeted cost of work performed. The budgeted cost can be considered the earned value of work actually. So earned value, we're looking at the benefit of making that cost. Schedule variance is a result of comparing the budgeted cost of work scheduled to the budgeted cost of work performed. If the budget for the work performed is greater than the budget for the work scheduled, the result is favorable. So we budgeted for $100, but the work itself only cost $70. That's a favorable event. And you see some examples in the chart on page 2.2.43, Earned Value Management. So you kind of have two charts. Project A, B, and C. You have the budgeted cost of work scheduled planned, schedule variance, budgeted cost of work performed, cost variance, actual cost of work performed. So if you can picture a line down the middle of budgeted cost of work performed, put a line straight down there. And you can first compare. So cost variance is the actual. So we're actually doing a schedule variance. So schedule variance is comparing the budgeted cost of work schedule to the budgeted cost of work performed. So it's minus really. So you look at the budgeted cost of work schedule was $487 on the example on page 43. And the budgeted cost or the value of the work performed was $483. So we came out on target. Our estimate equals our actual value, $487. Now we look at project B. The budgeted cost of work schedule, what money I set aside for the schedule, and the value of the work at the end was only $216, but I budgeted for the value to be $250. The actual value was only $216, so that's unfavorable. That's not good. Project C, the budgeted cost of the work schedule, the planned work, we expect it to be worth $719. The budgeted cost of the work performed, the value of the work performed was $847. And you can see how that's favorable. So that's your schedule variance. Then if you put a line in front of budgeted cost of work performed and you hide everything to the left of that, you'll see budgeted cost of work performed, the value, cost variance, and actual cost of work performed on page 43. So if the value of the work performed is valued at $487 and the actual cost of the work performed is $487, we can say that we are on target. If the budgeted cost of work performed is valued at $216, the value of the work is $216, but it actually only cost us $122, then that's favorable. That's a good thing. It's valued more than what I paid. The budgeted cost of work performed is $847, but the actual cost of what it cost me to make that purchase is $875. So that's an unfavorable event. So you can kind of see how the earned value management variances are calculated. So it helps to put it in a chart. Page 44 looks at program evaluation and review techniques, the PERT document. PERT is a method to analyze multiple tasks. So if you have a contract that has multiple tasks, you can break the task down into various projects and timeline, weeks, and then it's able for you're able to break down the events and the individual costs for each one of those events to kind of track how much you are on target. That's the PERT. On page 45, you look at the Gantt chart. Another way to display your schedule and resources required. When are you going to need the resources? Week 1 versus week 7. So this type of chart is useful for planning and scheduling projects. The Gantt chart is better at displaying the schedule and resources used in a project. That is the PERT method. So you can kind of read through that. I won't spend a whole lot of time on these because they're pretty straightforward. What we need to get to is on page 46, Introduction to Economic Analysis. So economic analysis is a systematic approach to the problem of choosing the best method of allocating our limited resources. And we also want to consider the state of the economy as we're estimating what it's going to cost us to make a purchase 1 year, 2 year, 3 year, 4 years down the line. Page 47, economic analysis defined. Understand that the primary basis of an economic analysis is the comparison of estimated costs against anticipated benefits. So it's not just, well, we go with the cheaper one or we go with the most expensive one. What are the benefits that we are able to get from making that purchase? An economic analysis is prepared using a net present value basis in compliance with DoD guidance and regulation. And we're going to look at those. You have the steps on page 49 of the economic analysis process. Establish your objectives. You can read through that. Page 51 gives you some method in how to identify different types of benefit. Understanding that benefits may be quantifiable, meaning that I can put a cost on it. So if our production increase, and I can say based on from one time frame to another with the same resources, that production increased by dollar amount, then that's a quantifiable benefit. So on page 52, the three quantifiable benefits are cost savings, cost avoidance, something I no longer have to pay. So that cost is eliminated based on the decision that is made, or productivity improvement, my timeliness or productivity improvement, something you can place a dollar amount on. That's your quantifiable benefits. So page 53 is a chart of types of measures and sample measures that you can look at. Increase the number of commodities or items produced. So whether it's number of hours flown, number of meals served, and so forth. So you can look at that. Page 54 looks at some non-quantifiable benefits, things that are beneficial to the overall operation, but you can't necessarily put a dollar amount on these. And you have a large chart on page 55 with those, such as morale. That's a benefit if it enhances the morale of your personnel, but you can't necessarily put a price ticket on your level of morale. So non-quantifiable benefits and quantifiable benefits. All right, we're going into statistical overview on page 56. Statistics, meaning now you're going to have to do some calculations. So you have to pay close attention to this section because you have formulas to do these calculations, and formulas will not be given on the exams. You have to remember what the formulas are. So descriptive statistics on page 56 describes a collection of quantitative information in a way that is easy to understand and interpret. And basically from this, the results, you're able to then determine what's the best decision for me to make or for that decision maker to make. So the most common types of descriptive statistics are, and we're going to look at them, measures of central tendency, measures of dispersion, frequency distribution, and skewed distribution. I mean, the numbers are all over the place. All right, so page 57 are your measures of central tendency. one that we're familiar with, your mean, median, and mode. There's a formula for mean. That's your average. So if you're given 10 sample numbers, you have to add all 10 and divide by 10. That's your mean. You're taking the average. The median, if you have 10 numbers, I will advise you, put all 10 numbers in numerical order, because most likely they're going to be all over the place. Put them in numerical order. Then the median represents the middle number. So if you come to the middle and you have two numbers, then you need to add them, divide by 2, and get the number that's in between. So median is the middle value. And if you have all 10 numbers in numerical order, you ask to calculate the mode. The mode is the most repeating value within those 10 samples. So the most frequent occurring score within that list. So that's your measures of central tendency. Reveals how data are grouped and what is typical about them. The measures of central tendency are the mean, median, and mode. On page 58, we begin the measures of dispersion. How spread apart are these 10 values that we talked about? So you have measures of dispersion are your range and your standard deviation. So your range is, if you put all 10 numbers in order from the smallest number to the largest, you'll be able to see the smaller number, you'll be able to see the larger number. So the formula for the range is your large number minus your smaller number. So the range is often used to describe the limits of your sample data. And it gives you the formula, and it's actually written. So if you don't read where it says range, you wouldn't know that the formula is to subtract the smallest number from the largest number of your sample. The standard deviation is a measure of how a set of values is spread around the mean. So you have the mean, and then you have various values around the mean. So a standard deviation could be 1 standard, 2 standard, or 3. So at the bottom of page 2.2.58, you have 68.27% falls within 1%, 95.45% falls within 2 standard deviation, and 99.73% falls within 3 standard deviation. And you can look at that. So that's your measures of dispersion. And you're going to have to do calculations for all of these. On page 2.2.59, it's your frequency distribution. How frequent do these values occur? So arrangements of values that show the number of times that a given value occurs. You may display the frequency distribution in a histogram, which is the bar graph at the top of page 59, top left. The one to the left is the bar graph, and the other one to the right is frequency polygram. And that's the one that we use most for the line graph. It's also called the line graph. Skewed data is represented on the beginning of page 59 at the top, meaning either all your data is all to the left. We don't have that normal bell curve. It's not a normal where some of your values on the left, you got your mean, and some on the right. So skewed data, in many instances, data will not fit neatly into the standard distribution model. Occasionally, data may be grouped in a distribution that has multiple data points on one or the end of the spectrum, and it gives you an example. So the one on the left, the skewed distribution on the left, is positively skewed because the tail falls off to the positive direction. If you look at so the left is negative, the right is positive. The tail skews off to the right, it's a positive. Conversely, in the chart, the negative skewed data, the most of the data on the right of the chart, and the tail falls off in the negative direction. Hence, it is called a negatively skewed distribution. So what you also have to ask yourself is, so what? What does it mean to me? So let's look at this example. For example, in a sample of a shop repairing a piece of equipment, we could expect the technicians to repair the equipment in a specific period of time. But in some instances, the equipment repair may take longer than expected. We can see this in the chart time to repair, showing most of the data on the left. This is described as a positively skewed distribution. The data on the right is when all the data falls to the right. So it depends on how long it's taking. Time to repair versus time to failure is positively skewed. So it's not taking them, it's taking shorter time to get the job done. Negatively skewed, meaning it's taking individuals longer to be able to accomplish the mission. So you kind of have to look at it like that to get the so what out of it. On page 2.2.60, inferential statistics is the other type of statistics. And inferential statistics include methods used to examine a sample of a population and make inference. So based on the data or the percent change, we can then infer what the sample size is all about. So you have proportion and percentage. So you have a percentage amount, proportion, like a ratio. So proportion is the statement of equality between the two categories. The bottom line is there's formulas associated with the proportion, and there's a formula for the percentage change. You see the new change. So you have examples at the bottom of page 60. Review those, because it's going to say if your inventory was X amount on January 1st, now it's February 1st, and you have a different inventory number, it's going to ask you, what's the percent change from January 1st to February the 1st? And so you can see the examples at the bottom of 60. Measures of correlation. How well does the data correlate one to another? So the best way to understand that is to flip to page 2.2.62. Measures of correlation. So you're looking at two data. On the left is productivity versus examination scores. So we look at test scores and we look and see, do they relate to productivity? And as you can see on the chart, the data on the chart on the left show there's a strong positive relationship, 85%, between training scores and productivity of the test takers. Therefore, it can be assumed that the higher the training score of the individual, the higher the productivity. So you're comparing training scores, test scores, to productivity. And those with the higher scores, higher productivity. So because each one moves the other one, then you can say they have a positive correlation. Those two things correlate one with another. The middle one says measures of correlation, negative correlation. The data in the middle chart indicate there's a strong negative relationship between training scores and the number of errors made by the test takers. Therefore, it can be assumed the higher the training score of individual, the fewer errors that individual will make. This indicates that the higher scoring individual will be more productive. So negative correlation. So this indicates the higher scoring individuals will be more productive. The last one says there's no correlation between age and the examination score, the test scores. Data in the chart on the right show there's no relationship between training scores and the age of the test takers. Therefore, no assumptions can be made relative to the training scores of the individuals who took that test. All right, so that takes care of that. On page 2.2.63, we move into linear regression. If there appears to be a linear relationship between the variables, it is then possible to plot the data and determine the best fit straight line. So you put all your points between the examination score